This is my Scrum Master, Evan Dowling, and some developers, Adam LaPlante and Daniel Matheson. We worked on the collaboration platform for machine learning and deep learning, and our client was Phong Tran from Newark. So I'm going to pass this off to Adam right now, who's going to tell you guys about the technology underlying our project.
Thank you, Patrick. So before we begin talking about our project and the actual problem that we're trying to address, we want to talk about the main technology behind our project, and that's Docker virtualization. So Docker is a software service that performs operating system level virtualization. What that means is that Docker can create virtualized applications. These applications will then share and abstract the host machine's operating system. Now, if you compare that to a traditional virtual machine, which has to create and maintain its own operating system separate from the host machine, a Docker container is extremely lightweight and it's extremely easy to deploy, those being the two main benefits of using Docker. So just to elaborate on what a container actually is, it's a standardized unit of software containing all of its dependencies. So essentially, a container is an application and environment all packaged as one. A container can be run on any host machine, provided that that host machine does have Docker installed and running on it. A container is created from an image just being a template used to create a container. The diagram on the screen now depicts the relationships between images and containers. First thing we want to point out is that an image must exist before a container can exist. We also want to show that multiple containers can be created and exist simultaneously from a single image. So now that I've talked about the technology we use, I want to talk about the actual problem that we're trying to address. At Newark, data scientists often have to use machine learning frameworks in their projects. To use these frameworks, they have to be downloaded as standalone applications, which often have high system requirements and many dependencies. So, they often have to spend time trying to troubleshoot their environment to match the application's needs. We were tasked with coming up with a solution which can mitigate any time lost in troubleshooting through the use of Docker virtualization. So, our solution is a web application. This web application will allow the users to log in and create a project, which will then be associated with a Docker image of a machine learning framework. Once this project has been created on our web server, they'll be able to access it and then launch that project as a container, where they'll be able to do any machine learning work they have to do. So, our solution eliminates any need for them to install anything on their own machine because we use Docker virtualization and we use it on the web server. And by eliminating any installation, we've also eliminated any time lost to troubleshooting. We've also enabled collaboration amongst data scientists by allowing them to share their projects with each other. So for the technologies that we use throughout development, for our front end, we use an AngularJS JavaScript controller. We use Bootstrap CSS for our stylings. For our back end, we use a Node.js server paired with Express routings. We use a MySQL database. And we also use an Nginx reverse proxy to allow multiple containers to attach to the same port simultaneously. As stated before, we did use Docker for virtualization. So the diagram on the screen now depicts our backend configuration. The main thing that we want to point out here is how heavily dependent our actual application is on Docker itself. So on the screen, you'll see 4 separate containers. At the top of the screen, you'll see a container for our SQL database. In the middle of the screen, you'll see a container for our actual application. In the bottom of the screen, you'll see 2 separate containers. One for any machine learning framework that's spawned from the application, and another for our Nginx reverse proxy. As for communication amongst the containers, the application database container will speak directly with each other. The application container will spawn any machine learning framework containers, and the machine learning framework containers will access their port through the Nginx reverse proxy container. Now I'm going to pass it back to Patrick.
All right, so let's get a little more specific here and talk about the actual functionality of this application. So let's say I'm a user, I was just hired at Newark, I'm going to start doing some machine learning research. There's an account already created for me, so first, I'm going to have to log in. Once I log in, I'm going to have to create a project. Now this is going to associate a project with an image that's already in our system to allow for this research. Once I've created a project, I can then go in and create the container. I need to be able to run the container, open the container to make any changes that need to be made. I need to pause, resume, and stop the container. I need to be able to commit images of the current state of the container. Now what this means is that the current state of the container is going to be represented with an image which can be shared with other users. This is the collaboration portion of this assignment. So when another user logs on, they'll be able to create a project based on an image another user committed. From the administrator perspective, we need to be able to create users. So when a new person is hired to work in this department, they call up the administrator and say, I need an account. They give a username, a first name, last name, email address, and we can create them an account. We're also going to have to be able to manage these users. So if, for example, an employee gets married, they change their name, we can go in, we can change their last name. We can also delete any users if someone has, say, changed departments or left the organization. We can also manage the containers. So if a user has left a container running for too long without making any changes or using it in any real way, we want to be able to clear up that space that it's taking up on our server. So as an administrator, we want to be able to close down these containers that are not actually associated with our own account. So why don't we move over to the demonstration now so you can see this in action. Now for this, it's running on a Linux server, so we actually have this running in an Ubuntu virtual machine right now, which you can see Evan is logging into right now. So the first thing that's going to be displayed is, of course, the login page. Now Evan's going to log in as the administrator account we have set up on this server. Click login, and the first thing you're going to see is the projects page. This is a list of all the projects associated with this user. So the administrator's been working for a while, and administrators do function as full users on top of all the other administrative functions. So they have all of these projects currently associated with their account. Let's go now to create a user, or to manage users. So what they're going to see is this table of all of the users that are currently in the system. And let's say this is too many users to look at at once. We want to kind of see a smaller number. We can go up there, and we can change this to only represent a few users. And there's also pagination at the bottom. We can just click next and continue through like that. So let's create a user. So we're going to click the create a user. I'm going to say it's going to ask for a username, a first name, last name, email address, and a role. The role, of course, being either administrator or standard user. So for the purposes of this, we're going to make the John Smith account, and we're going to make him just a regular user. So once he's created, we're going to go to the search bar, and we're going to type in John, because that's his name. And as we see, the account comes up in the search. You can search by first name, last name, username, or email address. You can't search for several, just for one. And of course, you can still paginate through if there are more results. So let's log out now, and let's go to this new user account. So the first thing you're going to notice is we are directed to a prompt to immediately change your password. So this page is the same as if a user wants to voluntarily change their password, but on first login we require that. So you enter the old password, which was automatically generated on the user's creation, and then you enter the new password 2 times to make sure they entered it right. So when we reset the password, it's going to then direct them to their project list page. And this is a new user. They don't have any projects associated with them, so right now it's just going to show a blank list. So let's go to create a project. So we click the create project button, and if we just, let's just give it a name. We say it's demo project. And if we just immediately try to create the project, it's going to say, no, you need to be associated with an image, because a project without an image doesn't mean anything to our system. So if we click that drop down for images, we're going to see all the images that are currently available to the system. For this demonstration, we're going to use the TensorFlow image, which is a common machine learning framework that would be used in situations like this. So let's create the project. Now we're getting directed back to the project list page, and we're going to see that this demo project is now shown. So let's click on the name demo project, and we're going to see the project-specific page. The name is displayed at the top. There's a toolbar showing deactivated and activated buttons. The activated buttons are the ones that the project in its current status can actually use. The deactivated ones are the ones it cannot use. So all we can do right now is create. So if we click create, we're going to see that you need to name this container before you actually create the container. This is to ensure that other users and administrators are going to know which container is running for which project. So we're going to enter in the demo container name, then we're going to click create, and we'll see that under container info, it's going to change the status to created. Now this doesn't mean anything's actually happening yet. So let's click run. I'm going to start running all the threads involved here. So once this happens, it's going to change the status to running. It's going to show It's going to show the ID of the container and all of that from the creator. It's going to represent that in the log. Once it's running, we can then open it up to see what that container contains. So we click open. For the sake of most machine learning images, it's going to show a Jupyter notebook. So for the purpose of this demonstration, that's what we have displayed. Now let's go back to the application, and we're going to pause this. Let's say I'm a user who needs to work on a different project for a while. Things don't need to be running, so I pause it. If we go back to the container page and reload it, we're going to see it never gets a response. So go back to the application, and then click resume. We go back to the Jupyter notebook and refresh it. We're going to see this time we do in fact get a response. And if we go back to the application, let's say we've made some changes in the Jupyter notebook. We want to share that with other users. So we stop the running container right now. And as you see, again, the status changed to stop. And all these changes are represented in a log at the bottom of the screen. And then we want to commit these changes to a new image for other users. So we enter an image name under the image name field. That's in the project settings section. And so let's remember that the name of this is demo image. We're going to reference that later. So we click commit. So this saves the current status of it for other users. And there we go. So we're going to start running this container once more. And then we're going to log out and go back to the administrator account. So the administrator account that we were on before, the same credentials as before. All right, so we're brought back to that project list page. Nothing's changed for the administrator because it's not their project that we created. Now if we go to the Manage Containers tab, we're going to see all the currently running containers for any user. Only administrators are allowed to see this page. We don't want other users to have that information or be able to make the changes we're about to make. So if we go to the Actions button next to the demo container, we're going to see that the buttons that would be active on the project-specific page are the options available to us now as the administrator, except for the create and the commit functions. So why don't we stop running this container here? And as you see, we have a little loading bar at the top to represent that this is loading, it is trying to do that. We have all the buttons deactivated, so there's no invalid functions that would be run during this waiting time. So let's now remove this container. It's been on the system too long, no one's been using it, we kind of just need to get rid of it. So we'll click remove, and as you see, it disappears. And if we were to log back into the user account, we would see that reflected in their project. So now let's go to the Manage Users page again. And let's say that John Smith that we just created, he transferred to another department. Or let's say that he firstly got married and changed his name. Let's go to edit his profile first. So we see he's no longer Smith, he is Stewart. Sure, changed his name. So we have John Stewart now. And it will be reflected in the table, and it will be reflected when we try to search for it. So let's now say, yes, they've left the company, they're no longer going to be working for Newark, or at least this department. We need to get rid of their account. So you see, we can change their status to deactivated, and that's going to allow them to no longer be logged in. So let's go back over to the slideshow now to wrap up some of this presentation. So of course, as all the groups did in this senior design project, we worked with a Scrum methodology. So that meant that we met up 3 times a week for 15 minutes for stand-ups. Ideally in the workplace you'd want 5, but as students 3 is what we could manage. So those would be discussions of what tasks we're currently working on, what we planned to work on, what roadblocks might be in the way. We also had meetings among the group to discuss any more advanced technical matters that couldn't be fixed individually, that needed to be sort of hashed out in a more discussion manner. We also had planned demonstrations whenever there was as Scrum defined, deliverable product to show to the client. And we had meetings with the stakeholders whenever, well, at the beginning it was every week. The stakeholders would be the TAs and the professors, anyone who has any stakes in the project who is not a developer or the client themselves. These started weekly. They later moved to about monthly once the project was really going. And then for So for the software that we used to collaborate as a team, we used Trello for task management. It was free, it was simple, it was good software to use for that purpose. We also used Slack for team communication, so we'd all message each other if we wanted to find out anything or run something by them, but quick communication, nothing too elaborate. We used Google Docs to collaborate on things like an architecture document or a user guide, a deployment guide, and we found this the most simple way to deal with this. To develop the software itself, we used the really high-tech Notepad++ to write the code. We also used Sublime 3. And for version control, we used Bitbucket with SourceTree to commit our changes. We like Git. So I'm going to open the floor to any questions now.